Hey everybody, so in this video we're going to talk about domain and range. Okay, so the first thing we want to say is what is the domain and range? Okay, so the domain is all possible input values for a function, and remember we normally associate the input values with x. Okay, so this would be normally associated with x. Okay, so then the range okay. Okay, so the range is all the possible output values. And again, this would normally be associated with y. Okay, so we're going to go over some examples about how to find the domain and range, okay, given all of the different ways that we can talk about functions. Okay. Okay, so the first way that we talked about functions was using an x and y table. Okay, so if we look at the x and y table, okay, so this represents a function, okay, and we can see that because each x value has exactly one corresponding y value, okay. Now, if we're looking for the domain and range, the domain is going to be all of the x values for the function. Well, here's all of the x values for the function, so we can really just make a list. Okay, so my x values are -2, -1, 0, 1, and 2. Okay, so that's my domain. It's literally just a list of all possible x values for this function. Okay, then the range, we're also going to make a list, and this will be all values of y or all values of f of x, all the output values. So we're going to list these: -3, 0, 5, 2, and 7. Okay, you can see that this list is not in any particular order. That's fine. But one thing I will say is that you shouldn't list any repeats. Okay, so if something shows up in your list more than once, you really only need it once, right? If you're making a grocery list, for example, you wouldn't put bananas at the top and then bananas halfway down. You only have to include it one time, even if you would like more than one banana. Okay, same here. Even if the value appears more than once, you only have to list it one time. Okay. The next way that we know to represent a function is with a graph. Okay, so let's look at some ways, some functions that are represented by graphs, and we'll look at their domain and range. Okay, so that's what the directions say. Find the domain and range of the function represented by this graph. Okay, so here we are looking at this graph, okay, and our domain is going to be all of the associated x values. Okay, so when I'm talking about x, I'm looking left and right. Okay, so if I start on the left here, I'm seeing my smallest x value, which is -2. okay? Then I'm going to move to the right until I get to my largest x value, which is here. That's 1, 2, 3. Okay. Now you can see these dots on the ends of the graph. That means the graph stops at those points. Okay. Now we're giving this range of values in interval notation. Okay. So remember, the open dot means it's not included in the graph, so we would use parentheses. And the closed dot means it is included in the graph, so we would use brackets. Okay. We're going to do something very similar for the range. Okay. So we're going to start, when we're looking at the range, right, that's y values, so we're going to look up and down on the graph. So we're going to start at the bottom of the graph, which is here, the lowest point of the graph, and that's at -2. Okay, then I'm going to move up until I get to the top of my graph, which is here at +2. Okay, again, this point that associates with the -2 is open, so we're going to use parentheses. Okay, and this one is included, so we're going to use brackets. Okay. All right, so let's look at our next graph. Okay, so we're going to start, when we're looking for the domain, on the far left. So here's the far left of my graph, and this is at -2. Okay, and then I'm going to move across the graph to the right until I get to the end. 1, 2, 3, 4. Okay. This dot is open, so I would use parentheses. This dot is closed, so I'm going to use brackets. Okay, very similar to the domain that we saw over here. Okay, so let's look at the range. Okay, so now I'm going to start at the bottom of the graph, which is here. This is at -2. Okay, and then I'm going to look up to the top of my graph. This is the top of my graph at 1, 2, 3. Okay, this dot at the bottom is open, so I'm going to use parentheses. This point at the top is included, so I'm going to use brackets. Okay. All right, so let's look at some graphs that are a little bit stranger here. Okay, so these are some unusual graphs that we did talk about when we talked about if something's a function or not, right? But we really haven't seen a lot of graphs that look like this since. Okay, now I'm going to start from the left. Here's my point on the far left. This is at -2. Oh, no, it's not. 1, 2, 3, -3. Okay, and then I'm going to move across the graph, okay, until I get to this break. Okay, now I have to look at this and decide if there's a break in the x values or if the x values continue. Okay, now here you would move along until here, okay, and then as soon as you're at the end here, you would jump up to the top part. Now you can see there is a jump in y values, but the x values continue immediately. So because there's no break in the x values, I don't need to make a break in my interval. Okay, and this is going to continue all the way until 1, 2, 3. Okay, this point is closed, so I'll use a bracket, and this point is closed, so I use a bracket. Okay, again, because there's no break in the x values, I don't need to make a break in my interval. Okay. Now let's look at the range. I'm going to start at the bottom, which is at -2. Okay. And then I'm going to move up until I get to the break, right? Starting at the bottom, going up to here. Now I can see that my y values are ending at this point, and there is a gap in y values. So I'm going to end at 1, and that point is included, so I'll use a bracket. Okay. Now my y values start over at 2, okay, and they continue up to 2, 3, 4 at this point. Okay. Okay, this part is open, so I use a parentheses. This point is closed, so I use brackets. Okay, we have two different intervals because there's a gap in the y values here. Okay, and I would combine them using the union. Okay, now this graph is very similar. The only difference is this one has a closed point here and this one has an open point here. Okay, so let's see how that affects the domain and range. So for the domain, okay, again, I'm going to start over here at -3. Okay, and when I get to this point, there is a point that has no corresponding x values, right? There's no x value of -1 in this graph. So it's going to go up to -1, but it doesn't include -1. Okay, it does include -3 because that point is filled in. Okay, then I'm going to start over. It still starts at -1, okay, but it doesn't include -1. That's an open point. Okay, and then it goes out to 1, 2, 3, which is included because that point is closed. Okay, so this is how you exclude a single point, right? This means everything between -3 and 3, but not -1. Okay, and that's what we see here, right? Everything else is continuous, right? It all goes together except for this one point where we're missing this single x value. Okay, then let's look at the range. Okay, so we're going to start at -2, and that's included just like before. We'll go up to 1, that is now not included, right? So we can see that that's the difference in the range here. Okay, and then we're going to start over at 2 and go to 2, 3, 4. Okay, which is included. And we combine them with the union. So the only difference between the range here is that one is included or not included, but it makes a huge difference in the domain, right? Because this has no missing x values, right? It belongs here, whereas this one has a missing value of x. Okay. All right, let's look at our last set of graphs. Now these graphs should look familiar to you. They are transformations of the base graphs. Okay. Now the domain for this one, we're going to start on the far left. Well, this arrow points off to the left, okay, meaning it continues off to the left. So that goes to -infinity. Okay, then we're going to go to the right. Now that continues off to the right, so that goes to +infinity. Okay, and we always use parentheses with the infinity symbol. Okay, now let's look at the range. We're going to start at the bottom of the graph, which is at the vertex, right? That's at -2, and that point is included. Okay, then as we move up the graph, we can see that it continues off to infinity. So that's going to go to infinity, and we always use parentheses with infinity. Okay, all right. Now let's look at this one here. Okay, put the domain below it. So we can see that this points off to the left. So this is going to start at -infinity. Okay, then it continues, right, up to this vertical line, which is at 2. Okay, now this gets closer and closer to 2, but it never actually reaches 2. So we put that it's going towards 2, but we don't include 2. Okay, then it starts over on the other side. So this part is also getting closer to 2, so we start at 2, okay, but then it continues off to infinity. So this is going to go to infinity. Okay, again, this graph never actually touches this line, so we want to use parentheses to show that it's not actually reaching that value. Okay. So again, this is how you show that you're leaving something out. You stop at that number and use parentheses, and then you start at the same number and use parentheses, right? So this means all numbers except for 2, okay? And that's what you can see. Everything, but not exactly 2, okay? Then let's look at the range. So I'm going to start at the bottom of the graph. Now this points down, so that would start at negative infinity. Okay, it goes up until here at -1, but it doesn't actually reach -1. Okay, then it starts again on the other side of -1, but it doesn't actually reach it. And then it goes up to infinity. Okay. Combine the two different intervals with the union. Okay, so again, this means all numbers except -1, right? We're excluding -1 from the range. Okay, so there are some examples of how to find the domain and range of some more common looking graphs, some of the base graphs that we've seen, and then also some unusual looking graphs with the holes in them. Okay, let's look at the last type of example that we're going to do. Okay, now this relates to when you have a function that's represented by an equation. Okay, so let's look at our two functions that we see the most. Okay, I should probably put f of x on. Okay, and these two base functions will let us talk about the general rule for finding the domain. Okay, so when you're thinking about finding the domain algebraically, okay, it's easier to think about what's not in the domain. Okay, so what you're asking yourself is, what am I not allowed to plug in for x? Okay, so for part A, what are you not allowed to put into square roots? Okay, well for part A, you are not allowed to plug in negative numbers. Okay. Okay, so our domain is going to be everything that isn't negative, right? This is excluded from the domain, so we're going to have our domain be everything else. Okay, so we're going to start at 0, right? And then go to infinity, right? Including all positive numbers. Now, always use parentheses here. Okay, and the question here, whether we should use parentheses or brackets, is, are you allowed to plug in 0, right? Can you have square root of 0? Yes, you can have square root of 0. So that means you want to include it with the brackets. Okay. Here, for part B, we're looking at what can we plug into a fraction. Okay, well the only problems you can get from a fraction is that you don't want the denominator to be 0. Okay, meaning in this case, because the denominator is x, you don't want x to be 0. Okay, so we're going to write an interval that means everything except 0. So negative infinity up to 0 and exclude 0. Then start again at 0 and exclude it up to positive infinity. Okay. All right. let's go ahead and look at a couple more complicated examples that are really based on these rules. Okay, so I'm just going to point out the main things that help us find the domain algebraically. Okay, you would want no negatives in a square root. Okay, and no zeros in the denominator of a function. Okay, so these are our two main rules that we're going to use. Okay, so let's look at, like I said, some more complicated examples of this. Okay, so for these two, they're both square roots, right? So we know that the main thing we're focused on is that the inside of the square root, which is called the radicand, right? The x minus 4 part should be a positive number or 0, okay? So how would we say that? The inside part, x minus 4, shouldn't be negative, so it should be greater than or equal to 0. Okay. So this is coming from the information that when you have a square root, you only want to plug in positive values, right? Non-negative values. So this would tell us that x should be greater than or equal to 4. Okay, and then we can write this as an interval 4 to infinity. Because it's greater than or equal to, we're going to include 4. Okay, and then we always use parentheses with infinity. Okay, we're going to use the same idea for part B. We want the inside part, which is x plus 2, to be greater than or equal to 0. Okay, this would tell us that x should be greater than or equal to negative 2. Okay, and we'll write this as an interval, negative 2 up to infinity. Always use parentheses here, and because it's greater than or equal to, we're going to use a bracket. Okay, let's do some examples with fractions. Okay, so the idea here is that we don't want the denominator to be 0. Okay, so we don't want the denominator to be 0. Okay, so we're going to think about what we would plug in for x that makes the denominator 0. I'm sure you guys can see that if you plugged in x equals 2, you would get 2 minus 2, which is 0. Okay, so we don't want x to be equal to 2. Okay, so we're going to write an interval that means everything except for x equals 2. So negative infinity up to 2, exclude 2. Start again at 2 and exclude it, off to positive infinity. Okay. So again, this means all numbers except for x equals 2, which is exactly what this means, right? Everything except 2. Okay, one more example like this. Okay. So again, we don't want the denominator to be equal to 0. So we're thinking about when is this going to be equal to 0? Well, we know how to solve this, right? We can use factoring, we can use extraction of roots, we could use the quadratic formula. So let's give factoring a try. Okay, so what multiplies to negative 12 and adds to 1? I think it should be plus 4 and minus 3. Set each of my factors equal to 0. Okay. And now I have the two values that would make the denominator 0, right? So this is what we don't want. These are the bad values of x, okay? So we're going to exclude them, negative infinity up to negative 4, okay? Start again at negative 4, okay? Well, we can't go off to infinity because we also have to exclude 3. So we're going to go up to 3, exclude it. Start again at 3, exclude it, and now we can go up to infinity. Okay, so now we have these 3 different intervals, but you can still combine them with the union. Okay. All right, those are the 3 main ways that we'll be looking at domain and range. From a table, from the graph, and then algebraically just the domain. We won't be finding the range algebraically because it's a little bit too advanced for where we are right now. Okay, let me know if you have any questions, and I'll see you guys soon.